Hi, Assalamualaikum everyone. So today we're going to learn system of linear equation. So what you need to know about the system is that we have three types of solution, which is many solution, uniquely one solution, and no solution. So how are we going to find these three types of solution? We'll be using these two methods here, which is the Gauss elimination method and Gauss-Jordan elimination method. If you want to learn more, please keep watching this video. And Iza will explain more about these two methods.
Hi, Iza is here. Okay, alright. Now we go to solving of Gauss of elimination method and Gauss-Jordan elimination method. How to solve it? So we must have operations. Okay, we have three operations. First operation is we interchange of Ri and with Rj. So Ri will be changed with Rj. Okay. The second operation is we multiply Ri with a constant non-zero. Alright. So let's mean 2 times Ri. So it will be Ri. Okay. The third operation is we multiply Ri with a non-zero constant C and plus with Rg, and it will be Rg. Alright? Okay. Now we go to the method.
Hi, my name is Fazurin. Thank you, Iza, for passing the topic to me. Okay, so this is the Gauss elimination method that I will explain to you. So this is the solution we have solved, and this is the properties for Gauss elimination method. So the first properties is the zero row must be placed at the bottom of the matrix, which is this one. You can see that this is the zero row, which the leading one is here. And for non-zero, for the second property is non-zero row, first entry is leading one. We can see that at the example here, the leading one is at the first place, and the second row is switch to the right, like the staircase. And the third property is two consecutive non-zero row with leading one shaped stairs like this. You can see that every leading one is moved to the right. So I will pass to Iza back.
Alright, now we go to Gauss-Jordan elimination method. Okay, Gauss-Jordan elimination method, we look at the row, okay, row and column. Okay, this is the row. So each column with leading one has zeros everywhere else in that column. That means the leading one above and below of the leading one must be zero, all zero. Like this is the leading one. So all of the above leading one must be zero. Above and below leading one is zero. Below of the leading one is zero. So that is a Gauss-Jordan elimination method. Gauss-Jordan also we call it a reduced row echelon matrix. REM, this is RREM. This is the REM. This REM. We reduce from here. We make it a zero. Okay, that means a reduced row echelon matrix.
Now we move on to Gauss elimination method. So this is the example questions written. As we can see, the system linear equation is in form of this, like this. So the first step we do is the first step is which we write like this in the form of 1. We because this is 1x, 1y, and 3z. So 1, 3, 2, 3, and negative 1. Because z is negative and 1. Negative 1. And 5, 7, and 1. Because z is 1. So, and the second step is we write the variable, which is x, y, and z, and we equal it to the equal, which is 1, 3, and 7, like this. And the second step is we write it as augmented, which is 1, 2, 5, 1, 3, 7, 3, negative 1, 1, and like this, and 1, 3, 7. So this is the basic step that we should do before we continue the further solution. Okay, so we start with augmented. 1, 2, 5, 1, 3, 7, 3, negative 1, and 1. 1, 3, and 7. So we start here. And the second step is we write as negative 2 R1. Negative 2 R1 plus R2 is equal to R2. Because we want to eliminate 2, we want the number 2 to be 0. So it forms like this. Okay. As you can see here, that 2 is equal to 0. 2 is now transformed to 0 because negative 2 multiplied with the row 1. Negative 2 multiplied with row 1 is equal to negative 2. Negative 2 plus with row 2. Negative 2 plus with 2 is equal to 0. And we continue to the next number. Okay, so the third is we do it like negative 5. Now we want to eliminate 5, number 5. We want to make 5 equal to 0. So negative 5 R1 plus R3. This is the R3. This one is R2 and this one is R1. So negative 5 multiplied with R1 plus with R3 is equal to R3. R3 will change the number here. So 1, 1, 3, 1, 1, negative 7, 1, 0. And now we do the row 3. So it will be 0, 2, negative 14, and 2. And the fourth step is we want to eliminate 2 to transform negative 14 to be 1. Or if it can transform to 1, or else it will transform to 0. So 4 is negative 2 R2 plus R3 is equal to R3. Okay. Same as 1, 1, 3, 1, 1. Because R3 is changing, so we write R1 and R2 first. 0, 1, and negative 7. So negative 2 R2, negative 2 times R2 is equal to negative 2 times 1 plus 2, 0. Negative 2 times negative 7 plus negative 14 is equal to 0. And negative 2 times 1 plus 2 is equal to 0. So here we can see that the bottom row is 0. So this we can conclude that this matrix is have many solutions. So the solution is we can write the solution like this: x plus y plus 3z is equal to 1. And y minus 7z is equal to 1 because we take this first row and second row, because third row is equal to 0. So we want to know the value of each variable. So we write this one, and it will be the solution. Solution is x is equal to, we write x, y, and z first. So z is t, because from this we want to take y, which is y is equal to 1 minus 1 plus z, 1 plus 7z, sorry, 7z. And x is equal to 1 minus y minus 3z. Okay. So from here, z is equal to t. T is real number. Okay. So when t is real number, y is equal to 1 plus 7z, means 1 plus 7z t. X is equal to 1 minus y minus 3z is equal to 1 minus by 1 plus 70 minus 3z. 3z is 3t. So like this. Yep. And then we calculate the value to get the x, which is equal to negative 10t. So this is the solution for the equation given. So we can conclude that z is any real number here. So we can, if z is any real number, we can get the y, the y values, the value of y. And after we get the value of y, we can substitute it in equation, the first equation, which is x plus y plus 3z. 3z, we know that t is equal to any real number. So x is equal to 1 minus y is equal to 1 plus 7t minus 3z, because we write it here. So we can get x is equal to negative 10t, y is equal to 1 plus 7t, and z is equal to t. That's all from me. I will pass to Iza.
Now we go to Gauss-Jordan elimination method. Okay, Gauss-Jordan elimination method is a reduced row echelon method. Okay, so the first step, same with a Gauss elimination method, like Pazurin teach you all. Okay, the first step is A, B equal to AX. X is okay, A is a coefficient, X is a variable, and this is a constant. So here is 0, 1. So A is 1, 0, 4, 3, negative 1, 2, 5, negative 1, 11. And X is X, Y, Z. Okay, this is a variable, and B is a constant, 4, 2, negative 1. This is the first step. Second step, we do the augmented matrix. Okay, augmented matrix A, B. Okay, A is a coefficient, so we make a coefficient here 1, 0, 4. Okay, 3, -1, 3, -1, 2, 5, -1, 11, and B is a constant. We put here constant 2, -1. So now we must apply a operation in elementary rows. What is the interchange or multiply and add. So for this first step, I will here 1, 0. So I want to make this value 3 change to the 0, value 0. So I make it, I multiply -3 multiply row 2. This is the row 2 multiply row 2 plus I'm sorry, this is a row 1. -3 we get multiply with row 1, which is a 1 here, and we plus with row 2, and will be a row 2. So okay, so here we copy tablet for row 2 we here 5, -1, 11, -1. Okay, so -3 times 1 is -3 plus 3 is 0. -3 times 0, 0 plus -1 is -1. -3 times 4 is -12 plus 2 is -10. And here same is -10. Okay. Okay, next we want to make 5 is 0. So -5 R1 plus R3 will be R3. Okay, 1, 0, 4, 4, 0, -1, -10, -10. Okay, -5 times 1 plus 5 is 0, -5 times 0, 0, -1, and -5 times 4, -20, and it will be -9, and here it will be -21. Alright, so here this is -1, so the leading each row must be 1. So this is -1, so we must make it 1. So how? We multiply, use operation multiply. So R negative R2. Okay, this is row 2. So negative R2 will be changed row 2. So 1, 0, 4, 4, 0, -1, -9, -21. So row 2 will be changed 0, 1, -10 will be 10 and 10, constant 10. Alright, -1 will be 1, -10 will be 10. Okay, after that, for the Gauss Jordan, the above and the below of leading one must be 0. So here must be 0. How we want to make 0? We use the second operations. We make a second operations. So R2 plus R3 will be row 3. Okay, so here will be 1, 0, 4, 4, 0, 1, 10, 10, and for the row 3, 0, 0, 1, -11. After that, we must make the above of leading one is all 0. So I want to make this 10 to 0. So -10 R3 plus R2 will be R2. So here 1, 0, 4, 4, 0, 1, negative 10. Negative 10 times 1 is negative 10 plus 10 is 0. Negative 10 times negative 11 plus 10 is 120. Okay, 0, 0, 1, negative 11. Alright, so and we have 4 here, so must be 0, and we do the third operations, which is negative 4 R3 plus R1, it will be row 1. Okay, so here 1, 0, 0, 48, 0, 1, 0, 120, 0, 0, 1, negative 11. So here is the answer is x equal to 48, y equal to 120, z equal to negative 11. This is the answer. Alright?
So, we will move on to the inverse of matrix. I will show you how to solve the size of a 2 by 2 matrix. So, the first example will be 2, 3, 4, 5. Okay. So, for 2 by 2 matrix, we will use one formula, which is 1 over AB minus BC times with BA negative B negative C. So, we will find the inverse of A using this formula. So, this would be A, B, C and D. So, 1 over 2 times with 5 minus with 3 times with 4. Okay, and then you times with 5, 2, negative 3, negative 4. Right? And then you get negative 1 over 2 times with 5, negative 3. Okay. So the final answer would be negative 5 over 2, 2, 3 over 2, and negative 1. Okay, so Ain will show you further details on how to solve matrix that has the size besides 2 by 2 matrix.
Okay, let's move on to the inverse of a matrix, which is other than 2 by 2 matrix, which is we can use by 3 by 3 and above matrix. The form is like this. This is the matrix A, which is this one, and then this the identity of A. If you want to know the identity, we look at the matrix. Matrix is this one. Matrix A is 3 by 3. So the identity will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So, and then we are going to use Gauss-Jordan elimination method, which is we reduce row echelon matrix to get the inverse A. So let's go. This is the matrix of A. It's 1, 1, 0, negative 3, 6, 5, 0, 1, 0. And then we write in the form of this one. So 1, negative 3, 0, 1, 6, 1, 0, 5, 0, straight line. And then 1, 0, 0, 0, 1, 0, 0, 0, 1. And then we start we go to reduce row echelon matrix. We got this leading one, so we want to reduce negative 3. So we have to times -3 R2 R1 -3 R1 plus R2 equal to R2. So we get 1 1 0 1 0 0 and then 0 1 0 0 0 1. Then we get this one -3 R1 plus R2. The changes is on row 2. So it will be 0, it will be 9, and it will be 5, will be this one 3, 1 and 0. So let's move on. This already have leading 1. So we are going to make 9, this number 9 into a leading 1. So we times R2. The changes row is on R2. Let's go here. Then 1 1 0 1 0 0. Excuse me. 0. Okay. 0 1 0 0 0 1. So the changes is on row 2. So the answer is will be 0 1 5 over 9 1 over 3 1 over 9 and 0. So and then we're going to eliminate either row 1 or row 3, doesn't matter. We just reduce the row 1 first. This one we want to be a 0. So let's negative R2 plus R1 equal to R1. So the changes will be on row 1. So the rest will be the same. 1 5 over 9, 1 over 3, 1 over 9, 0. And then the third row is also the same. 0 0 1. So the changes from the row 1 is 1 0 negative 5 over 9, 2 over 3, negative 1 over 9, and then 0. So, and then after this, we want to reduce the row 3. We want, and then we do the same. Negative R2 plus R3 equal to R3. So the answer, the changes will be on row 3. So the rest is will be remain the same. So 1 0 negative 5 over 9, and then 2 over 3 negative 1 over 9 0. And then the second row will be the same. 0 1 5 over 9, 1 over 3, 1 over 9, and 0. So we go changes. The third row will be 0 0 negative 5 over 9, and then negative 1 over 3, negative 1 over 9, and then will be 1. So the next step, this is already reading 1. This is already reading 1. This column already reading 1. So we want to make this negative 5 over 9 into 1 so that it can be a reading 1. So we go to negative 9 over 5. So the changes will be row 3. So we go R3 equal to R3. So we go, the rest will be the same. So 1 0 negative 5 over 9, and then 2 over 3 negative 1 over 9 0. So The second row remain the same. 1, 5 over 9, 1 over 3, 1 over 9, and 0. So the changes will be row 3. So 0, 0, negative 9 over 5 are 3. So negative 9 over 5 times with negative 5 over 9 will be 1. So the rest will be 3 over 5, 1 over 5, and negative 9 over 5. Okay, next step will be, so this is already reading 1, so we want to make 0 for both of these columns. So we are going to reduce this one first to make a 0. So negative 5 over 9 R3 plus R2 equal to R2. So the changes will be in R2. So the rest will be the same. 5 over 9, then 2 over 3, negative 1 over 9, 0. 0, 0, 1, 3 over 5, 1 over 5, and negative 9 over 5. So the changes of the row 3 will be 0, 1, 0, then 0, 0, 1. So we continue. We want to eliminate negative 5 over 9 into 0. We make negative 5 over 9 into 0. So ini negative. So we have 5 over 9 R3 plus R1 equal to R1. So the second row and third row does not change. So 0, 1, 0, 0, 0, 1. Then third row 0, 0, 1, 3 over 5, 1 over 5, and then negative 9 over 5. So the changes in row 1. So we are going to 2 times 1, 0, and then this 0. We get 1, 0, and negative 1. So we already get the identity for the A, for the matrix A, which is we are going to be like this. This one identity and this one the inverse of A. So the inverse of A is 1, 0, negative 1, and then 0, 0, 1, 3 over 5, 1 over 5, and negative 9 over 5. So this is the answer.
This is the end of this video. So I hope that you enjoy it. We wish you all the best. So yeah, bye!